Yes, first little piece, and then I'll swap you.
All right, perfect.
Okay, gang. Good afternoon. Welcome back. Session 2. I have just a couple of real quick things to go through. I'm going to go over kind of what the agenda is today, some of the follow-up items from last time, and then we're going to hand it over to Michael. We've adjusted the agenda just a little bit based on some of the commentary from last time and some of the follow-up items that we had talked about. So, Michael, if you wouldn't mind clicking me through there. It goes somewhere. Aha. Okay. Video recording is in progress, right? So we're going to record the screen this time. I think that it'll allow for when I upload this video for you guys that you'll be able to kind of see this instead of this and me, and I'll kind of put both of them together so that it makes some sense for you, so that these video recordings can be really useful for you. So there was some awesome information in the last video, some things like, where do I find that menu again and where is that stuff? You should be able to go back to that video and find those things. This one will be much better now that we have kind of the screen recorded, but please remember that they're there. Last week's video is already uploaded. It's on this QR code. I'll send out the link. At the end of the day, we're going to get everything uploaded to a YouTube channel that Josh owns, right? So that you guys can share those videos and view them at any time on any mobile device. And they'll all be up on YouTube, and you can scroll through and go through the agendas and figure out what parts and pieces you're looking for. So I think that'll be really useful when it's all said and done here. The sign-in sheet is going around. Please make sure that you sign in on that thing if you haven't already. Just pick that guy up, and then we'll do those evaluations here at the end. It's the same evaluation except for the disagree column that is there now. So please help us with those. We took that information and kind of build up what we're doing. So here's what we're going to do today. 90 minutes. We're going to try and get out of here by 4 o'clock. Brief introductions, just a few minutes of Michael, who he is, where he came from. We did our introductions last time, so we won't kind of go through that every time here. The follow-up items from last week I'll go through real quick, and then here's what we're going to talk about. So the request was really, hey, the patient rooms on level 2 are acting funky. Show us how those work. So the first thing we're going to do is go through basic VAV operation. Michael's going to go through just a few slides of like, what is a VAV and how does it operate, right? I know that most of you understand that and know that, but for anybody who's coming along with everybody else, we want to make sure that we bring you all along. So we'll do a quick introduction, and then we're going to go through in detail those patient room controls. And look at those pieces, and then we'll jump back over and do the navigation and overview part 2, but we'll look at some of the more detailed features, right? We'll look at the trending, we'll look at a brief overview of the reports, the alarms, and things like that. We'll do a Q&A, and then the evaluation there at the end, and any feedback you guys have. So, brief introduction. Michael, Halcombe, just who you are, where you came from, and what you're doing here.
So I'm actually one of the owners of ES2. Started the company 12 years ago now. This month will be 12 years. Worked for a successful controls company across town. We wanted to kind of do things a little different, me and my business partner, and really focus a lot on the energy. And that's some of our name. We strictly probably go by ES2 more nowadays today than engineered systems and energy solutions. We didn't think that out very well, because if you try to put it on something or any letterhead or anything, it doesn't fit. But anyway, we really wanted to. We believe in controls, and believe that controls can really help customers diagnose, troubleshoot, and save energy. And so it's kind of in our name. So engineered systems, energy solutions. And we believe in doing custom applications. So the more complicated, the bigger the system, more complicated you can make it, the more we love it. You know, to do a rooftop unit in a school is not real challenging for us. But when you do a hospital with all the pressurizations, you got the laboratories, chill water plants, and everything that has to come together, integration with other systems, we really. That's our cup of tea. It's what we love to do. So we not only do controls, but we do test and balance and commissioning, energy audits, a bunch of other stuff. So in Oklahoma City, we got 3 offices. In Oklahoma City, we've got about 40, I think we're around 48 employees now in Oklahoma City. Tulsa, we got around 18, and then Arkansas, we got 4. So So we got 3 offices, Oklahoma City, Tulsa, and Little Rock. So.
And for the context of this job, ES2 did the controls and the test and balance. They did not do the commissioning piece. That was our TME, part of our separate arm of the design team that did that for us. Thanks, Michael. So a couple other things for me, click through there real quick. So here's follow-up stuff from last session. I told you that's kind of what I can do for you, so that's what I want to do. Some specifics of what we talked about. The alarm retention, there was a question about how long do those things stay in the system. The answer is 7 days from the time that they are cleared and acknowledged. It is fully adjustable, so if you want them longer than that, all you got to do is ask. We can do that. And Michael, maybe today you can show how to adjust that, and that way you guys can adjust it yourselves. Next one. The ED on occupied mode, Robbie, you mentioned this. So the ED was under its own tree previously. It is now underneath the Oklahoma Heart Hospital tree in the control sequence there. That is all about the occupied and unoccupied schedule that applies to everything down that tree. So now it is in the 24-hour occupied mode. I don't know exactly when that changed, but you should not see anything going into unoccupied mode across anything that ES2 has touched. It is all 24-hour operation now. Patient room temperature controls, we're going to address that today, right? So the request was, hey, how do these things work? What's going on with them? We're going to look specifically at those today, so I'll just kind of leave it at that for now. Working with reports. So this was a follow-up item when we were talking about it. I kind of jotted this one down, actually. We went briefly through where the reports are, but we decided that we really need to break out a separate session to show you guys a little bit more, maybe it's not all of you, but some specific people about how to set up and run those reports for specific things that you want to do. We're going to touch on them a little bit today in relation to the level 2 patient rooms, but we'll set up another one to the curriculum so that we can really get that like advanced kind of how do you set up a report and how do you do all that stuff. It's not very intuitive, right? It's a little tricky, so it does require a little training to know how to do that stuff.
Well, and I would piggyback on that.
Yeah.
Anything that you can make a report out of a system or out of a database, so no matter what kind of report you want to see and how you want to see it, it has so many options. So that's why it's kind of hard just to go up and show you a report when anything can be created out of it. So to me, it's a totally separate class, and we'll do it. It's on our agenda to do it down the road, but we will do it. So
yeah. So you guys decide who needs to be a part of that, but we'll get it all on the schedule, and then we can let you know when that'll be. Here's just some little feedback points from the last survey, right? Handouts of the key points from the presentation will be helpful. So on the back of today's agenda, we listed out key points. So these are just like a quick list of what we really want you guys to be able to take away from today. So that's there for you. Hopefully you find that useful. Better camera angle, so that's why we decided to record the screen so you can actually use the information and see what's going on there. And then keeping the material relevant to the audience, right? Keep that technical jargon to a minimum, right? You guys aren't programming this thing, but you need to know how it operates and speak in the terms of the way that you will be using the system. So we're going to do our best, and that one's probably a little bit of a learning curve for us, right? For all of us. So we're going to try and do better, and hopefully you guys will let us know if we do. Learning objectives for today. So really after today's lesson, you guys should be able to describe the operation of the standard VAV box operation, review and adjust the set points for the VAV operation throughout the whole facility, troubleshoot common issues with VAV patient room VAVs. We want to make sure that when you get the call that it's too hot or too cold in here, you know exactly where to go and how to troubleshoot that, right? You know what to do from a operation standpoint. We're going to show you how to do it from the system standpoint, right? Where to go and what buttons to click to get you the information you need. And then how to navigate and utilize trends, schedules, alarms, time lapses, and some reports, right? We won't go overly in depth into the reports piece yet. I think that might be the last one for me. Yeah, so Michael is going to kick it off with kind of how the VAVs operate. So if you I'll click for you now.
Okay.
And we'll swap.
So VAV box, when I hire a new employee or when we hire a new controls guy, test and balance guy, it's the most populated piece of equipment that you have in each building, in every building. I mean, every time we do a hospital, big building, we did Devon, all these large facilities, VAVs, the number one, is the most common equipment in the building. So what I want to try to do, and this is going to get technical, but I think hopefully it'll help you see, once we move to the graphics, how an actual VAV box works. This may be repeating something you guys already know, but it's something that I train all my guys on first thing. When we hire them on, this is the number one thing, because you're gonna see more of them than any other piece of equipment. So you gotta be able to, you kind of know how to troubleshoot the airflow, water flow, things like that, what's could possibly be happening, so. But, so this is kind of a drawing of a typical VAV box, right? And you guys have probably seen it, you got a damper here. The damper is hooked up to a controller. The controller will modulate the damper to maintain the flow. So what the number one thing that the VAV box does is it measures flow, measures a volume. And so a lot of questions are well, how does it do that? What's the magic behind it? How does it measure the flow? So in the end of the box, you see we got a differential pressure transmitter, and that's what this DPT stands for. And the differential pressure transmitter is measuring the difference between total static and external static. And the difference between those two, total static is, if you can imagine the air's flowing down through this duct, right? It's flowing down through here, and the pressure hits the end of this tube. Well, that pressure hitting the end of the tube is more than the pressure of the static pressure. Static pressure is like when I blow up a balloon. If I take and I blow up a balloon, the more you blow on the balloon, the bigger it gets. The more pressure I'm putting externally on the actual walls of the balloon itself. And that's what this static pressure is. So static pressure is, I always refer it to bursting pressure. So if you can imagine in your head the amount of, when the pressure is in, it's forcing out on the ductwork. So as you're pushing more air through the ductwork, it's causing pressure to push out on the ductwork. Does that make sense? Total pressure is got static pressure because it's pushing out, but it's also the pressure that's going directly into the tube. I mean, it's the inlet of that tube and it's going straight into the inlet of the tube. So this pressure is more than this pressure. So go ahead and jump to the next one. So with those two probes in the ductwork, or in the VAV box, you have total pressure was the air coming in, static pressure was the pressure of bursting pressure. If you subtract the two from each other, then you end up with the velocity pressure. So jump back to that slide. So if I subtract this pressure from this pressure, the pressure difference is just the pressure running down the duct. Does that make sense? You guys follow me? And you can stop me at any time and say, hey, you're not making sense. But the static pressure, if you subtract static from the total, it gives you velocity. Velocity pressure is the velocity pressure. It's actually the velocity of the air running down the duct, right? Okay. So go ahead and jump to the next one. So, math class, no, I'm just kidding. So in order to figure out what the velocity of the air is, it's a simple formula. And the VAV box measures the total pressure, subtracts the static pressure, and gets the velocity pressure. And using this formula, 4,005 times the square root of the velocity pressure, this is a constant, and it's about a formula this long, but we're not going to go on that, you don't have to know that. 4,005 times the square root of the velocity pressure gives you feet per minute. So if I measure 0.25 inches, because we measure static and total pressure in inches, if I measured 0.25 inches, take the square root of that, end up with 0.5 times 4,005 with a feet per minute of 2,002 feet per minute. All right? It's just a math equation. Going to the next one. So knowing that so now I know the velocity. I got 2,000 feet per minute coming into the inlet of the VAV box, and now I need to know the duct size. So if I know the velocity pressure, and then I know the duct size, I can calculate the CFM. How many cubic feet per minute are going to the space? And it's just a simple formula. You take the air velocity, which is 2,002 feet per minute, times the area, and you end up with cubic feet per minute. Make sense? And that's just, finding the area of a square, finding the area of a circle, measure the velocity pressure, calculate the feet per minute, multiply the feet per minute times the area, you get your cubic feet per minute. That's how a VAV controller, the root of all these VAV controllers in that building, how they're measuring the airflow. And so you're wondering, well, why are you getting so technical? Why are you getting all the way down to that level? Because that's the number one, usually general problem. We'll get into problems here in a little bit. Problem we generally have with a VAV is going to be airflow, most often. Why? And generally with the airflow, maybe it's possible that the velocity pressure tubes, you guys will probably all be retired by the time that would ever happen. But if they could get dirty, not measure their airflow properly, or we had a problem in this has been a long time ago, Baptist Hospital. We were doing test of balance. I was trying to calibrate this VAV box. This is an old pneumatic VAV box. Same principle, it works the same way, but we couldn't get the velocity pressure in, and we actually took instruments and measured it. Messed with it, couldn't figure out what the deal is. We had the mechanical contractor separate the VAV box, the flex from the VAV box, and it was a pair of pants. How a pair of pants got in a duct and flew all the way down and got up against that velocity pressure probe, who knows? I can't tell you. But that was the problem, and we wasn't reading the correct velocity pressure with what air was coming out of the unit. So those kind of things. So does that, so far, I know I'm flying through this, did that make sense? Everybody following me? Yeah, please stop if you want to go into more detail. Next.
So Michael, is it your controller that does that math?
Yes. So the controller itself is doing all the calculations and everything else.
So the VAVs that are here, they're priced, I believe.
Yes.
And they have those sensors already mounted in
Yep.
them.
They came with the sensors already in them.
And you mounted the controller to them where they were done in the factory.
We shipped the controller to the manufacturer,
Yep.
and Price Industries mounted our controller in the VAV box at the factory, and then they shipped the VAVs to the job site.
Okay, so factory terminated from the sensors to your controller?
Yep.
Okay. And the controller that is there is an automated logic controller? Okay.
Yeah, and we'll take a look at one when we get into the graphics. I'll show you a picture of one, how to get to the see a cut sheet on it and everything. So, again, just math. A while ago I said we were going to take the got to find the area of, if we know the area and the velocity, feet per minute, then we can calculate the CFM, cubic feet per minute, right? So, just simple math, just as the example, you take an 8x8 duct, multiply 8 times 8, that's 64. Then we have to convert inches to square feet, and it converts to square feet is you divide 64 by 144. So basically we took a number of square inches and divided it down into square feet. And 144 comes from a 12 by 12. And then so if we took, back here on that other slide, we had 2,002 feet per minute, times 0.444. We should read 890 CFM at that VAV box. That makes sense. So that's how it does it. It's not all magic. That's what's cool about, I've always thought was the coolest thing about what we do, what you guys do, is it's science, it's mathematics, it's physics. It can all be calculated. You can figure it out. You can use a calculator and figure out almost everything we do. So anyway, hope that wasn't too deep, but that's how the actual VAV calculates the airflow. And then when we get here in a little bit, we're going to look at all the airflow set points and where they're at, how to adjust them, and all that. So, anybody got any questions on any of that? Okay. Well, let's jump into the graphics.
What's my website? What's my IP address?
Oh,
10.20.135.4.
There you go. I'll let you log in here.
Okay.
And then I can drive 45. Everybody get logged in okay? Everybody get, okay, cool. So you guys can kind of follow along today. Adding the computers is a great idea. I mean, I think that'll be really helpful if you guys really just kind of click through and follow along, and it really gets you used to what's going on and how to use this thing.
so let's talk about patient rooms. 'Cause that was kind of on our agenda, number one. One of the biggest confusing things, and one of the easiest things to read and confusing things that I want to just touch real quick, and I know Corey probably talked about it, is the colors. And I may be rehashing what he already went over. How much did y'all talk about that last time?
We actually didn't talk about that last
Okay,
time, so
okay,
that's
very
good.
good.
It's good.
Because not only is this going to be essential to the rooms and everything else, colors represent a condition in the space. And so the condition in the space, if you look down here at the bottom of the screen, green is ideal, cool is as you get cooler below the heating set point. So let me step back. So the green bar is, if you can imagine, the cooling set point is on the top end of that green bar, and the heating set point is on the bottom end of that bar, that green bar. Right, if I'm looking at that, just this green piece right here, the cooling set point is on this side of the green bar, and the heating set point is on this side of the green bar. Follow me? Heating's on the left, cooling's on the right. If the temperature in the space is anywhere between the heating and cooling set point, let's just throw some numbers in there. Let's say our cooling set point is 72 and our heating set point is 70. If the space temperature is 71 degrees or 71 and a half or 70.5, the space is going to show up green. All these spaces that are green are in between the heating and cooling set point. In between those two set points, and you guys probably have heard the terminology before, is in the dead band. So there's a dead band between heating and cooling, right? So 70, this space right here, this light blue, is directly below the heating set point. So if in the space we are 69.5, it's probably light blue. So all those spaces that are slightly below the heating set point are light blue. Does that make sense? So the idea is I can look at this floor plan and, let's go back. Vice versa, we're yellow, we're slightly above the cooling set point. This could be 72.5, right? Makes sense? So I'll tell you right now, if I look at this floor plan, the south half of the second floor, the whole floor is good except for these two zones. Or this whole section of the floor is good except for these two zones. This is something wrong. There's something wrong in this space because it's in the red. It's in alarm. This is probably 3 or 4 degrees off the set point. Or maybe 4 or more. The orange is probably 3 degrees or above that set point. So in one shot, I don't know how many zones there are, but go up to...
Hang on just a second. So when you adjust the thermostat, that bar changes with the thermostat?
Yes. Yes. So when the thermostat's adjusted, and we're going to get into that when we're talking to patient rooms, because I think I'll be able to clear up a lot of the diagnosis of what's going on. So you can look at, click on, up there at Super West. Not the Heart Hospital. No, that's not it. Go down to level 2. Well, just click on level 2, the whole second floor. So right now I think there's like 60-something zones on that floor, at least 60-something VAVs or so. In one snapshot, I can tell you where the problems are, where the VAVs that are not tracking to the set points are. Is these red ones, the orange ones, and if we have any dark blue ones, they're not tracking set point. There's something wrong in those spaces that we need to go investigate and look and see what's going on, because they're not tracking the set point. So the colors are meant as an easy way to snap through the building and diagnose what's going on in the spaces. Because how else do you guys generally know when you got a problem? Yes. You get a phone call, right? And so the whole goal of the colors is you can look through the building in a matter of a minute or so, look at 200 zones or how many zones we have, and you know problems in the zones that are out of bounds. So in this color bar, green is ideal, light blue or yellow is just slightly warmer than the cooling set point, light blue is slightly cooler than the heating set point. Light blues, yellows, and greens are okay. I can tell the conditions of the space by looking at those colors. Each one of these spaces right here is slightly above the cooling set point. Each one of these light blue spaces are slightly below the heating set point. I don't know what the heating and cooling set point is, but it doesn't matter as long as it's adjusted to where we allowed them to adjust it, and I can diagnose what's going on. So real quickly we can do that. So there's a lot of times there's confusion with what the colors mean, and that's the goal, is so you could quickly diagnose what's going on in the building. Anybody have any questions? We're going to get in a little more depth when we get into the spaces.
We've talked about color a few times, and historically, in the existing building and in MOB, one VAV may feed 3 rooms, right? So we often use that color sequence to link those 3 rooms to that one staff.
Yeah.
If we're using this as a tool, then how could we identify, 2 or 3 or 4 more rooms per
Good
zone?
question. Good question. So click on the south end down there, again, Joe. So let's take, so when you highlight over here, and this will show up better on your computer. See, it'll pop up ST248. If you arrow down to this zone, or this area right here, that one right there, ST248. So this VAV serves this whole area right here. Now, it also, you can't see it very well on the screen, but I bet if you look on your laptop, let's see if it shows up on you guys. So, yeah, just arrow over like the corridor right there, that blue corridor. Scroll down.
So you have to be drilled into first you got to be drilled into the area to get that.
Yeah.
You can't just look at the overall floor plan.
No.
Okay.
Because there's 2 rules of thought. And so we used to color all the actual zones, and you could see what was in those zones. But that information wasn't utilized as much as being able to diagnose and tell what's wrong.
Sure.
But you can tell what zones are feeding what if you drill in and highlight and go in. So like go to the corridor over there on the right. If you see over on the right as you highlight, look at over there on the designation of the rooms. It'll turn them from a lighter gray to a darker gray. see it, what happens when you highlight over it?
I do. You see, Robert, changes the text color.
Yeah, it changes it. It can be hard to see. And we've asked if they could modify it to make it more something different. But yeah, you can see it there. I didn't think it would show up very good on the projector. But in that space right there, you can see that it's feeding those two spaces. That ST225 feeds those two spaces. If you go to another space, it'll show you and tell you the VAV that is serving those areas.
And as you scroll over these two, they also pick.
Yeah, you can click on either way. You can click on the right and go to them, click on the left and go to them. Either way, it'll get you there.
But it changes, does it change the text color on the left? Looks like it was.
It's just changing.
It's
So
just
if
on the right.
When I roll over equipment storage, it also dims telemetry office because they're tagged.
Yes,
the same.
because they are
Okay.
fed by the same VAV.
And like if I hit office, then office and shared office share VAV too.
Got it.
In the same way over here.
And so there's a way to drill down and see which ones are fed by what space, because they share the same spaces. It's just different than we've always done it in the past. But I feel like the troubleshooting, to be able to diagnose all the spaces quickly and fast and tell what's going on, because you don't care about what's, if that, what was that, telemetry office and equipment storage are shared together. So if if that space, if they were both showing up red or something like that, you could drill down and find out what spaces those are serving in that way. It's kind of different and backwards, but I think you get more information on the diagnosis of the condition of the space. And so that's one of the things that's kind of probably different than what the system that you have on the other side, or what you've been used to seeing. But there's a way to drill down and find the information. It's all in here. It's different, looks different. It's a different location, but it's there.
So talk to me, guys, about how you use that information, right? So you get a call, it says the telemetry office is warm. You go check out the telemetry office, say, okay, that is, click on that guy, go look, it's this. Here's what's going on with it. Now, what I want to know is, what else is it feeding, right?
Well, first, what I'm looking for is where's the thermostat? If it's feeding multiple locations.
Okay.
Where's the
Where's the
thermistor?
thermostat? Yeah. So
Right.
how do we tell that?
So back up.
Yeah. Good.
Each one of these T's where the thermostat's located.
Got it.
This temperature, humidity, temperature, each one of those T's represents the location of the actual thermostat.
So these two
So
rooms.
telemetry, and so has the thermostat in its office, and equipment storage doesn't have one.
Got it. So you do that from the floor plan, and you go, okay, there's the thermostat that it's feeding. If you come over and hover over it, it tells you what else that VAV is feeding, so that you don't adjust something and unknowingly adjust another room, right? What other? I mean, I'm thinking through the workflow, right? And like, what are you trying to find and when, so that you guys can work efficiently, right? Make sure that it makes sense for you.
Well, it's kind of like tugging on the loose thread, when you get that call.
Right.
You have to figure out where the VAV is, where the thermostat's located, and then the CFM, how's it split and who's getting what, right? So it's multiple locations. Is it just divided equally? If the VAV's seeing 400 CFM, so it's 200 of it going to the telemetry office and 200 of it going, it's kind of a crapshoot, right? So then you have to go boots on the ground, look into this situation and see what's going on.
Yeah, and that's a good question too, is how do we know physically where the VAV is located? Is that from the plans, you gotta go then, from here, go to the mechanical drawings to find it?
Well, because oftentimes the VAV is not exactly where they had put it
Yeah.
on the mechanical plans. It may be over this way or that way, just however they could kind of get it pit into the area. So we went around, we had to check them all out and everything, but they, you'd have to look at some kind of mechanical drawings or something like that.
And so then I guess the question is there a way that we can either upload the mechanical plan right here?
So
to
let's talk about that.
Okay, in the
So,
documentation piece or?
let's jump into one of those VAVs.
Okay.
Just click on it. So right here is documentation pull down, sequence of operation, the control modules, cut sheet on the controller. We could, once TME, get all the as-builts done for the mechanical system, go back, jump back to the, see where we've done here.
Yeah, just put
We
them
could
right
put
here.
that as-built drawing on the floor plan plates, where you could click on it and go see it.
Yeah.
At least it would get you in the ballpark close of where that VAV, where you start popping your head in, looking. And it has the CFM numbers on the mechanical drawings, if we get the ductwork drawings. And the drawings are really, mechanical drawings with the ductwork and everything, they're really full. I mean, there's a lot going on those drawings.
So
But
I guess we
you
could-
can.
So I guess we could do a couple things there to help, right? Like we could
Yeah.
take a set of those as-builts and call them like the VAV plans, and we could highlight all the VAVs in red or something, or so that they're easy to diagnose. You pop them open, you go, here are all the VAVs. Here's the area I'm looking in, and there's the VAV. Right?
And it's just a link to
Is
the
it-
PDF,
Is
because
it
it's
not,
easy.
is it not possible to just update the background with those on there? Like if we were to give you a
It's
location.
so here's the challenge that we run into, is we kind of got to where, because of the overlay of those colors, if you go back to the floor plan,
Yeah.
this troubleshooting and diagnostic overlay that allows us to do all these spaces, it interferes with that. And then you end up with gaps and everything else.
Yeah.
But, I'll check and see. I don't wanna, cause when we get down to this level, it is pulling up, a graphic tool and start painting stuff in the space. So if you get by with just doing the as-built, I think it'd be easier for us. Because what happens is, when we start putting it on here, is the only time you guys don't generally go and just start looking at, every space in the building. You're responding to calls, and you'll go look at something if you see that there's an issue or something like that, right? And that's what the goal of this is to, don't waste your time here, because the space is satisfied. Don't waste your time in these, because everybody's happy. This one probably ought to look at, what is it? Well, I almost bet you I know what it is, because where the temperature sensor is, the sun shines right through that window on that floor, and it's on that column over there where the sun's hitting. I've watched it turn orange different days, and I almost know that's what it is. But that's what we want to provide, is the easiest way to troubleshoot, and then drill down, get you the information that you want, and how can we then make it easier. So,
Well, there's a thermostat in that room right there, and it's not showing.
MS office, bottom right, keep going over room.
That room right there.
That corridor and that MS office are on one of the stats right there where your
Yeah.
finger
Okay.
pointer is at. Inside the office there, right there, yeah.
Yeah, right there.
Yeah, outside the door, towards where.
Right.
so
Yeah,
you guys
there's-
don't go and call in there before.
And there's two showing.
And I know where that box is too. It's out there in the hallway above that hard seat.
One with valves.
Well, we'll send,
And it's green now.
Yeah, so.
What if is it feasible to go around and, with a label maker, and put ST251 on the grid wherever that VAV is located?
Yeah, we have the marks, at least like, hey, there's a VAV here. We can definitely go label them, yeah, that's doable.
Maybe we think about that.
Because then before you leave the office, right, you click on the plane, you go, okay, it's in that corridor. And then you just go out there and you should see a blue label right in that corridor and go, oh, there it is. You could definitely label them though, it's easy.
So any of y'all got any questions on the colors or what the purpose of them are, how to diagnose? Because every time we get a new customer, and it's so much different than what you've done in the past, that it does create, there is a learning curve because it's backwards from what you probably And it is, when we first went to automated logic, I had a hard time wrapping my head around it to begin with too. But I think when you start being able to see the spaces pop through the floor plan, boom, 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 this floor's good, this floor's good, this floor's good, I'm gonna go on and work on what I know I can work on. I think you'll see the value in just being able to quickly diagnose the floors. Because then, once we get an issue, so let's go click on the VAV and let's drill down into the VAV solution. That's part of my problem, because I'll start rambling and everything else.
And then it's
gonna
4
be
o'clock.
Yeah, it's gonna be 4 o'clock. So.
All right.
So no other questions on the colors? So here's where the colors come from. So if you look at this down in the green box, you look at this space, we are in CCU bed 6. The heating set point 70, the cooling set point is 72. But look here. The occupants got the space adjusted up 4 degrees. So that automatically made our heating set point 74 and our cooling set point 76. And so, because if I was to look at this and say, Michael, you just lied to us because you said a while ago that temperature's in that green space, then, or if the temperature's in between those two spots, then it's going to show up green. So this set point in the whole facility on all your equipment is the parameters you guys want them to maintain. And then you give them the opportunity to adjust it up or down a certain amount. So ideally, and the reason for this is, one, we're concerned probably more in hospitals and almost anywhere with occupancy, satisfaction and comfort and everything else, because you get people are hot, cold, people are sick, don't feel good, but we want them to maintain some kind of parameters. Because the reason is, if you back up to that floor plan, Joe, if this zone and this zone are not somewhat close, you will always be fighting each other. This zone and this zone are both in the corridor. These two VAVs, they will sit there and they'll fight each other all the time, because one set point's up, one set point's way down. You're right. One person is running theirs up to 85, one's running it down to 55, and the next thing you know, it becomes an energy hog, and you're fighting each other all the time. But if we can keep people satisfied and within an acceptable parameter, then it's win-win for everybody, because it's going to be a lot more energy efficient, because you don't have this zone trying to overcome the cooling of this zone, or this one trying to overheat the zone that's calling for cooling, and we can maintain reasonable parameters. So jump back in there, Joe. So this one's different. So jump back into the one we were just at, CCU 6. So right there is the parameters we want you guys, the facility, want them to maintain in the space. And then we allow them to adjust the thermostat up or down a certain amount. And when they do that, over here, you can see it changes the effective set point. And so when you look at it, this tube could be confusing, but that's not what this thermostat's set point is. That's what parameters we want them to maintain.
So which one drives the color on the floor plan?
This,
Right. Because it's light blue now, which means it's slightly below that heating setting.
yeah. Right.
Yeah.
So the set point 74 is slightly below the blue. Occupants happy, or it should be happy, it's right around the heating set point, where we're trying to maintain, and space pretty much satisfied, it's right below the heating set point. What do y'all typically, I know in the original sequence, and we're gonna look at the sequence here in a little bit, the sequence actually states that they maintain set point and then there's 1 degree above and 1 degree below. But what we ended up, I was talking with TME, again, when we met a long time ago, this was acceptable because it gives you the same thing, it's just where does this need to be set? So a lot of facilities, we set these to 75 and 70, 74 and 70, but essentially if we set it to 70 and 72, it's the same thing as having a set point at 71 and then having your up 1 and down 1, right? Again, it's probably different, a little different than what you guys have done in the past, but should give you the same results. But it allows us to be able to then give you the status colors and diagnose the space. Questions? Every time, so just click on that, Joe, or just click on the down arrow on that thermostat. See how it's going down? Now it's down to 3. If Joe hit accept up there, which he won't hit accept, I'm gonna make the page mad, but if you could do the same thing from here. The patient on the button on the sensor is do the same thing. There's a limited range at which we're allowing them to change that up and down. Okay. And I'll show you where all those
And that range
adjustments
is
are.
set at 0.
Huh?
That range is 0.
Now they can adjust it up 4 up or down 4.
What I'm saying is, that's from whatever that range is. If it's 70 degrees, then that's 0. And you can go plus.
Right, oh, yeah, yes, yeah,
You can go plus
Right.
4 or minus 4 from 70.
Yep.
Is that across the board in every space?
Should be in every space. And it
When
can
we're
be changed.
communicating with end users, it's good for us to know
Yes,
this, right?
okay, yeah.
So when we go to the nurse's station and they say it's 73, and you look at it and it's on +1, well, you say, we're plus, the way that this works, right? Now we're educating the people, the end users that are using it, is your base set point is 70. If you want to go 4 degrees above that, you punch it up to +4. You want to go 4 below it, or
Yeah.
vice versa, then you punch it down.
Mhm.
Is that appropriate?
Yep.
To communicate? Okay. I want to make sure that we're communicating the right thing.
How did you get to 70 as the set point? Like, let's use this one as an example. Is it that effective heating set point that gives us the baseline? Or is it 71?
It's what, it's wherever the last user that was on the front end left it. I would say one of my guys probably, or, I mean, you guys might have changed it.
You're talking about on that occupied heating and cooling, yeah,
Yeah, right here.
yeah.
You have to hit accept to see it change.
Yeah.
But if you go down to 0 instead of +4,
Yeah.
and then you hit accept, then your effective heating and your effective cooling changes on the right-hand side.
Yeah.
Right.
So in my mind, the neutral set point, what I would refer to as neutral, so it's your baseline, it would be 70 degrees. If you could just click accept on it real quick, Joe. Bump it down to 0 and click accept.
72,
Now they're matched up for what the
Now,
effective is.
now jump
for what
back
the
to your
set-
graphic.
Now it's showing yellow.
Yeah, now it changes the color because you've changed the.
Yeah, because you're slightly above
Yeah.
the cooling set point now, right?
Yeah.
So you could bam, you can see what's happening in this space. It's the same but different, right? Same but different.
So across the board though, I don't know, initially we weren't at +4, plus or minus 4.
See here, notice how the effective cooling and heating changes on the right-hand side? Go ahead, Brian.
But
Sorry.
but now across everything, that's where everything's at, the tower, ED, all that.
So I think what we need to do is establish that, where that needs to be with you guys. And I'll have somebody go through.
Well, every
the
room's
whole
different.
building. Yeah.
Patient rooms, we want them to have as much control as they can possibly have.
Right.
Period.
I think
And then we want a
we've-
quick response, which we went through this kind of on the preliminary front ends with TME. We don't want the fan to slow down to try to warm the room up. We want the damn
Right.
hot water
yes.
pool to open when they call for heat.
Yep.
Right?
Agree. Yep.
So,
That's the way it should be.
yeah, for patients. Now, for offices, calm down, nurse.
Yeah, okay.
Right? Give it 10 minutes and see if you like it. And we're flexible there. But patient rooms, there's no flexibility from our perspective.
Understand. So.
And then ORs would be the same thing. ORs and cath labs.
Yeah.
Docs, they want to warm the room up relatively quick. We don't want to have to go in and override shit every time we want to do that, right?
Yeah.
They should just do it because that's
Yes.
the operational culture,
Yeah.
within the building.
So, before.
Oh, sorry, I
we-
cursed on the video.
No. Before we get through.
Can you edit that out,
like,
Joe?
all the training and stuff, I think we could probably identify those spaces. And there's a way we can global modify all those set points real quickly and help get these spaces where they need to be. Because like Joe, go back up there and click again, Joe, on that, you clicked on 5 a while ago, I think, or
Yes.
7. So look at that one. That one's got a 4-degree deadband.
Which one is it?
So 4 degrees is not what what the sequence says, it needs to be 2 degrees if you're gonna go. But there's a lot of zones in the building that are set to 4-degree deadband. But in an office building, other places, schools, things like that, a lot of times it depends on the time of year, but 74 to 70, most people don't have a problem with it. Now you got some that probably feel the difference and they would, but, so those, we need to we can help you guys change all those to whatever. So my thoughts was 72 and 70, and then, but,
For me, I mean, you guys feel free to chime in here, but I'm not looking at this every day. But when I do look at it, I look at it occasionally just to help. And I love the fact that it's web-based, so I can go anywhere in the building and jump on there and check it out, right? But when you're looking at the trends up here in the top right-hand corner, shouldn't those lines basically be within a degree of one another? Or does that all depend upon the deadband?
it's are you looking at a different one, or is this one right here what you're talking
that one
about
pulled
too?
up. But I mean, that's
That's a good one.
relatively speaking.
So it is, I mean, that's part of these graphs, is you really gotta look at them pretty drill down in. So I think can you click on that one and open it on the graphic? Oh, yeah, very much.
It's super useful, but it's also somewhat confusing, because when I look at this, I see the set point's 76,
Which is what the effective cooling set point is.
and we're
Yeah.
riding around 72.9. Well, if I'm,
Well, we're heating the space up too, because there's a 4-degree deadband, we're trying to maintain that heating set point. And so there's a 4-degree deadband between heating and cooling. And so it's warming the space up to maintain that heating set point. We've never gotten warm enough to go up this high yet, because we're in between heat and the deadband all the time. That's what's happening on those. So we don't ever end up all the way up there. Now, in my opinion, this deadband probably needs to be like 74, and then it probably wouldn't look as crazy as what it looks. But it's actually controlling to the space set point, or heating set point. If it would be the same thing so on your Johnson system, you have a set point. Let's say if our set point is 73 on our Johnson system, would it look like the same thing on Johnson, except you would have one set point?
Yeah, you've got one average number that you're riding up and down.
And that's the difference, is we have 2 set points, basically. We have cooling and heating. Because there's the deadband for energy conservation between the cooling and heating set point, and that's why there's the deadband there.
So what you don't want is an adjustment of 4 degrees and a deadband of 4 degrees because the nurse is gonna say, I'm cold, I'm gonna bump this up, but it's gonna take the deadband up to 76, and it's not gonna do anything, it's gonna
Right.
say, I'm still satisfied.
Well,
And
it's
they're gonna
still-
say,
yeah,
it's
we're gonna
gonna
hang out at
+4, but
72
but it's
right
still gonna be cool because it's still
So
satisfied.
that's what I was
So
thinking.
that's why you gotta
I
tighten
think
up
that
the
deadband needs to be 2
Yeah.
degrees. It'd be closer to what you guys probably have on your Johnsons.
So what you're saying is, we need a tighter deadband
Yes.
and more plus and minus to be able to change the temperature, the effective
Yeah.
heating and cooling set points of potentially more than 4 degrees,
That's right.
plus or minus, to give them that comfort in those patient rooms to swing it. That's
Set
what it seems
everything
like
at
to me.
70 and 72, then they're gonna go to 76 is gonna be their top.
Yeah.
Which it could potentially peak at 74 and stop.
Right.
Right. That's
Well,
what-
it would-
Which it probably would hover around
Yes.
74.
It's only gonna warm it up to 74,
Yeah.
because you get the 2-degree deadband.
Right.
So if you run the set point up 4
So-
degrees, it's gonna heat up to 70.
So Michael, why not have a 1-degree deadband? Like what is that, what are
Because,
the
look at this.
implications there, the smaller, there's obviously a trade-off here, right?
You'll be constantly heating, cooling, heating, cooling, heating, cooling. He can be tuned and get closer, it's just, most people, most humans can't tell you the difference between 71 and 72 degrees, or 73 and 71. Now, you drop down, it'll get much cooler, you get much warmer, I can tell you the difference between 75 probably and 69, but it's most, I mean, they've done tons of studies, ALC hired a company and did studies, and their overall, say 74 to 70 is the most efficient place to run a building. And of all these studies, where you get the most efficiency out of your equipment.
So from an efficiency standpoint,
But
that.
you guys are also in a hospital too, so you got a kind of like hospitality. You got to keep it happy. So you make 2 degrees is not bad. It can stay within 2 degrees easily. And also look at that graph.
Well, you have to think about, hang on a second, but you gotta think about perspective. Managing perspectives, which is a son of a beep,
Yeah.
right, for your video. Because not everyone's perspective is the same.
Right.
So if you're a visitor with a loved one and the visitor's cold, but the loved one may be warm or whatever that situation may be, if they go bump that up plus 4 degrees and it rises from 72.4 to 74 and stops, that's not very satisfactory, right? They want to see that significant change so that they know that they have control over the system.
Well, and we can increase how far they can adjust it. That's changeable.
So the plus and minus
Yeah.
4 to
So
6.
you can change it to 12 degrees.
That's what I'm saying, I think
15
that's
degrees.
for patient rooms, tighten the
We
dead
leave
band,
ours
give
at
them more,
72 and 70.
ability to
and then we'll
change.
get going.
Yeah.
and let it
That's
lie
like
back.
them
I
little
think-
ladies that want it
Yeah,
80
it's-
degrees, I gosh, get it up there.
But it's also worth thinking about how the space is naturally heating or cooling at any given season, right? That's why this one's laying at the bottom, is because either like the door's open and the corridor's cold, and so it's naturally
You're
driving that
seeing
room
quite a
down.
few, this building's doing a lot of reheating.
Yeah.
A lot of reheating, because our temperatures on our air handling units are like 53 degrees
Right.
and stuff. When we've had like some rain, humidity things, when we've tried to compensate for humidity, it drives the temperature down to try to reheat the space back, so. Right now, if it's 85 degrees outside, I bet you that dude will ride right there. Nobody ever changed it all year long.
Robbie, where was that at?
I already called for it.
Oh, did you? Can I send her a message, let her know?
Yeah. So did y'all talk about trends or anything last time when Corey was here?
Just a little of kind of.
Did he show you how to control click on?
Yeah,
Okay.
yeah.
So that's another thing too, is this swing may look like it's a lot, but I don't know how much. Yeah, so go down to the bottom here, how long is that? Degree in about an hour. So it's maintained within a degree over an hour. So that curve, we can adjust the settings of, so go up here and click on that little deal. No, I just lied to you. What, we can change the way it looks, make that look like it's more of a hump and everything.
Basically,
else.
the resolution.
Yeah, the resolution, we can change it, make it look like whatever. Any questions on the set points and or the colors or any of that?
If we go in and change that, I think the cooling set point, is that on the actual bar trend on the bottom? That shows us it says heating 70 and cooling 74.
Okay, click on the X up
Right down here at the bottom.
there. Yeah, so if you click right here, click on the 74, make it 72.
Already got it on the set.
And hit save. It's done. Now you made it event 2 degrees. I mean, it's easy to change them. That's why I was saying globally, we can globally change a lot quickly. So now let's, since we just the parameters this is the parameters we want them to maintain. We can see what they've got it adjusted to where the set point's at now. Then let's go over here to the properties page and go to zone set point control and scroll down. Oh, yeah, I'm sorry. That's why Corey doesn't let me do this whole lot. Go over to the logic page. And click on the set point block right there. Keep on
The only person here that
going. See where all this can all be adjusted, those parameters. And what these other bars are, and you don't see them, but
Facilities,
those
Robbie.
are
Hey,
demand levels. So if we had a kilowatt meter, and we're not doing this in Harvest, but I want you to know what they are so that you, when you look at questions, have questions of. So this is the one we're actually using right here. It's our normal set point. If you just arrow
I'll
over
check
to
it.
that one, it's demand level 1. If we had
Okay.
a office building and we were trying to do peak demand shedding, if the electric meter went over a certain amount and we needed to knock those set points, it automatically relaxes the set points to keep the utilities underneath a certain peak. It'll do the whole building all at one time. It's very effective, and we've done a lot out in the state of Oklahoma, but you have like 3 demand levels and do it. We're not using those 3 here. It's not part of the sequence, but I want you to know what they are. Because it says demand level 1, 2, and 3. Tie the electric meter in, you can relax the deadband on all those zones, and the utility meter will just go down. It's kind of amazing that it actually works the way it does. Hospital, you don't want to do it because you'll have some patients that are upset. All right, so go to details, Joe. Scroll down, scroll down. So that's the design parameters we put in for design degree days. It has to do with optimal start-stop. So if we were using optimal start-stop, which again, we're not doing here, click on sensor. Right here. See that set point adjust limit? You can change it right there. So for each zone, so if you go into, click on this blue block in the logic, you go in, if you wanted to make it 12, whatever, you click on it, and you can run that they can run that thermostat up and down as much as what you want to allow it. Again, it's one of those things when we get done, I can have my guys do that, and it save you a lot of time. So I just wanted to show you where it's at. It's editable. It's down in drill, you just spot to drill down into it and get to it.
So from the logic.
So from the VAV, right?
Yep, to the logic.
To the logic, to that set point blue lock,
Yep,
and then
sensor,
sensor.
bam. Now, one thing we're gonna, when we get into the documentation and the help files, if anytime you got a question or something like that, you can go up there and click on that help button. I don't know, Corey showed you all that. Anything about the systems in there. I would just encourage you, if you're goofing off someday or whatever, dig into that help file. Because if you just type in set point adjust, search, it'll find something.
Look up administration stuff on it. So that you can start.
Makes sense?
I even tried to search for it and I can't pull it.
On the set point adjust, I may be calling it the wrong thing.
Because the only people that have logic on here are gonna be Scott, Ryan, and Josh.
Well,
Yeah.
very good questions. Makes sense?
So if you can't get to the logic, you can't adjust that? It's only doable from there?
No, and the reason, and that's one of the, it's kind of, because the system's set up based on levels. And so I figured if somebody, you can give somebody access to the logic page and not give them adjustments. So the system's totally configurable. I can show anybody the logic pages or show them whatever. It's just whether or not you give them permission to adjust the different things. All right, so let's jump back to the graphics. So here's the biggest thing. Remember when I was talking about CFM? Almost always, we've got a problem and the air handling unit's doing what it's supposed to. You got a good discharge temperature coming out of the VAV box. Do you have the airflow? So one of the things we try to do also is to keep the screen as simple as possible so you can look and see, is it doing simply what you need to know? Is it doing what it's supposed to do? If the space showing up orange, red, dark blue, click on it and go figure out, we can go figure out what's going on. Number one, is it maintaining the airflow set point? Yes, it is. Its set point is 325 CFM. The actual airflow that we're measuring is 336. So again, you can go and see what all those set points are if you want to drill down in the system. These numbers were provided by TME. So, and our test and balance team went out and calibrated every one of the VAV boxes, checked them, make sure that they're, when they say it's doing 330-25, that it's doing plus or minus 10% of that, right? So we go up to the properties page. There's multiple ways to get to the airflow. You can go to the airflow control here, click on flow control. So if we're trying to keep the pages easy to diagnose problems, easy to read, see what's happening, your real data and a lot of information you want to drill down and troubleshoot is on these properties pages, the IO pages, the logic pages, this kind of behind there. Because generally you don't want to, you can populate these pages with all this data, but there's no point if you're never going to use it. I mean, some of these VAVs you may not ever look at if there's not, unless there's an issue with it. But if there's an issue, where do you go find what's going on? So you can click on this airflow control. From right here, we're going to talk about a little bit about troubleshooting. If you arrow down a little bit, Joe, you see down here, this VAV doesn't have a fan, so you don't have to worry about that. This is just a can on every one of them, but this is not a fan-powered VAV. You can lock that flow set point to a particular number if you want to. So make it 400 and hit accept. back to the graphic.
You did it for us.
And so if you're troubleshooting, now you just locked it and you overrid it. I'm sure that's a word. I have to edit that on the video. I don't want to be caught saying that. So,
Hillbilly.
yeah.
Got lots of
So,
Keep it clean, all right?
yeah. So you can see a set point changed to 400 CFM. So that VAV damper should start opening up. So we're measuring again the velocity pressure at the end of the VAV, remember? It's going to measure that airflow and then should start opening us up. We're not too far away from set point, but it will start gradually, trying to get there. So that's one. So let's jump back over there, Joe.
So just out of curiosity.
Yeah.
How often does this happen, the perimeter download required up top left? It's on my
I
screen.
think it's because I don't know what y'all are messing with the same, or y'all doing the same one or different one.
Maybe.
Joe was double clicking and he got overzealous. Just go ahead and hit download. You're not going to hurt. Hit download, because what happened is the overall database has a mirror image of what's out there in every controller. What happens if you change something, and you apply a change, and it's already sent something to the controller, the database says, okay, we got another update and a different timestamp, and it says that it needs to be updated again, so it needs to be downloaded. So that's what's happening. So if you click twice
It's
real
like
quick,
a queue, ready to
Yeah.
get it to.
so just hit download, get it cleared up. So you can also override it to a particular position. So there, you can clear that there. If you're troubleshooting something, trying to figure out, do we got an airflow problem or what, is the damper actually a issue? So there is a ton of fire smoke dampers in this building. And if you look at the VAV, and you got zero airflow on it, then I would be willing to bet you it's a fire smoke damper, something like that, that's tripped. But there's some tools behind the scenes here that you guys can use to override things. Open, close, watch the airflow, increase, decrease, to verify that, the damper is operating properly. Say, yeah, you can cancel that. And then we'll go to details, Joe. Yeah. Here's where all your set points are. So these are all your CFM set points.
I didn't keep up. Where are we at?
So we're still back in the airflow control block.
Properties.
And then there's yep. And then details tab. So he went under airflow control, hit on flow control,
Okay. That's a step I missed. Got it.
and then details tab.
Info.
There's where all your, so let's talk a little bit about these set points. Cooling max airflow, heating max airflow, occupied min, unoccupied min, auxiliary heat min, and then dampers, or manufacturer specified airflow at 1 inch water column. This number right here, don't ever change it, because this is already set. Everybody, we did it when we calibrated them. We took the manufacturer's data, said what it's going to be at 1 inch, and then our tab guys adjusted or calibrated the VAV boxes, right? Now these other airflows, I hope you don't ever have to mess with them either, but you can change them. Once we get everything all done, tuned, tied in, the test and balance finished, it should be at what TME designed it at. And so, but if you have to increase the max cooling CFM, you can do it right here. Max heating CFM, you can do it right here. When the VAVs go into that temperature set temperature in the space drops below the heating set point, the VAV goes to this auxiliary min heating airflow set point. Let's go find another VAV that's got different numbers, because that's a constant volume VAV box. Let's go to like, it's probably a corridor VAV or something. Click on the one next door to it. Yeah. So go back up to properties. Airflow control. Yeah. See there, it's a little different. So our max CFM, so when we get in full cooling, we're going to expect that VAV box to go to 375 CFM. If we're calling for full cooling, it's going to go to 375. If we're within that dead band, if we're within the green area, that box is going to be delivering 115 CFM. Because it's minimal airflow, we don't need really cooling, we don't need heating, so it's going to hang out at 115 CFM. So you can see right there that why, they say 70 and 74, the wider your dead band, well, look how much we reduced the airflow from max CFM down to that. If we can longer we stay in that dead band, there's where the energy saving is in fan horsepower. But so anyway, if you're at minimum airflow, you're at 115. When we drop into that light blue, we start calling for heating in the space. The VAV box is going to go to 200 CFM because that's the heating airflow we need to warm the space up. Make sense?
Minimum.
Yeah.
Yeah.
Yeah, that's the minimum. It's the same in this building because it's the same. Because
Min and max are the same, got it.
yeah, because we don't have a morning warm-up cycle because you're always occupied. Now, if we had a morning warm-up cycle, generally this would be 375. Same as cooling. We would have the air handling unit start pumping out hot air. We'd warm the space up real quick, and then, but we don't have that part of the sequence. But so it'll be when you start calling for heating, it'll be at 200 CFM. Does that make sense? And again, click on the help button over there in the top right corner. Hope it doesn't make a liar out of me. Go down and you can click on how it works. It will kind of tell you how it's using those set points. This is probably the one thing that I was most impressed with when we demoed the software. When we first was looking for a product to rep, was the help files in it. Because they really did a good job of, at least you can go dig around and find it. It may not be super intuitive, but it's in there. Because most of the installation, when we install the files onto the computer, is these help files. I mean, it's a lot of data. So I encourage you, you ain't gonna break nothing, dig in there, so if you have any questions, figure it out. Okay?
So, 5-minute warning. Which is okay. I mean, we can push a few of the topics to next time.
Yeah.
I mean, we're totally flexible there. I want to be respectful of everybody's time. So maybe we should break there,
Okay.
kind of recap what we want to push to next week. But we didn't, we got to go through alarms and trends as it relates to the
Well,
VAV
we
boxes.
need to finish the sequence.
And we got to finish
So
this.
we wanted to try to explain, okay, this is where the set points are, this is how the VAV controls. Now, and let's talk about this. Let's try to tie this all together with the sequence that we currently have.
Yeah. So if it's okay, we'll pick up that stuff next time, and kind of take a little more of this stuff to next time. It's good discussion for sure. I mean, I think that this is useful.
What's the plan for labeling the STs to match the existing room title? Like, for instance, patient room 279 says CCU bed 7. How hard is that to change? Is that something we can do, or is that something that you guys have to do?
On what's?
The graphic on the labeling of the rooms.
Labeling of the room. So if you go to, I'm just looking at ST 259, CCU bed 7. Well, that's accurate per the floor plans, but that's not accurate per the end user. So for us, that's patient room 279.
Okay, so click on that, Joe. Go to, or I'll tell you what, go right here. See where it's at in the tree, right click on it. Go to configure, top configure. See where it says at the top, change it to whatever you want to.
Oh, cool.
So if they do change room numbers, things like that, then you can change it easily. If you tell us what you want, I'll make one of my guys change it for you. Or if you want, if you guys got updated numbers and all that, we can do it. So, but it's that simple to change.
I'm sorry I missed it. I see where you're at, but where'd you go to get it?
Well, that's too bad. You think, Brian, you should have.
Hey, snooze, you lose.
4 o'clock. So what he did is he right click.
Okay, configure.
So if you right mouse click, yeah, you go to configure.
Hey,
And just
All my computer whiz, I'll figure it out.
Just hit.
all right, Scott just ran out of here. He's got an air handler down. I'm not sure what's going on with him, but
All right, could be, yeah.
it's probably, hopefully a simple reset.
It's that simple to change the room.
MOB, I think.
So hit Control C,
Yeah.
Joe,
We're on
copy
controls
that.
training.
What is?
But I'll check in with him and holler back at you.
No.
Just put
I
some,
mean, I could give you the first one on
Okay, thank you.
the, hang on.
just hit apply there, and then jump back to the graphic.
Okay.
And updated it here too.
Yeah, it should, when you go back,
292. What's the last room over there, 292, so that's 291? Is that right? Anybody got that number right?
No,
I don't have that pop.
293.
294 is the last one.
294, so that's 293, yeah.
Yeah.
Okay. Yeah, I do have that written down here.
Joe put it in
Could
249.
have jumped in there and found it. Yep, 294, so that's 293.
So that's not the same name, is it?
294,
293.
293.
It's my dyslexia minus one kicking in.
Close.
So now so the equipment's not labeled right? But the
Right.
question is, how do you change that here?
So let's go to the top and refresh the graphics page. So let's go to, where's the refresh button? Go to the top, hit tool or something, should be a way to refresh that. Up there in tools, Joe.
Up here?
Tools.
The text.
See a refresh. Oh, go back to me. Hit refresh.
Yeah. I got it on mine.
You did? Well, Joe did something wrong.
On the
apparently, so he does.
On the tree, I've got 293.
He's not there.
So I got on the tree, but it doesn't update
Yeah,
the
it's
floor
on
plan.
the graphics.
Oh,
So you see
graphics.
the graphics? So
Sure.
that's what we're trying to do. I don't know, good question. I'll write it down. We'll-
Yeah, I'll write that down as a follow-up, we'll go over that.
Or even if, like, when we scroll over it, if it would show where it pops up the 259, the SP 259, if it showed in there, just help us find it. If you can't do it the other way, some way does.
There's a.
Okay. All right.
Cool. Well, sorry guys, I thought we was gonna run through, but like I said, Corey's probably better. I get to rambling.
Oh, you're good.
But I wanna make sure you, because it is, you guys got so many, and if you understand the colors, the dead bands, the temperature set points, how to get there for the VAV boxes, it's it's the same for every other piece of equipment, fan coil units, blower coil units, everything else. So I think we'll, it may be slower getting through these to begin with, and then after that, I think we'll probably snap this.
So a couple of follow-up items that I wrote down, and stop me if there's anything else that I should add to my list, right? So I would say that between now and Thursday, like, get in and play with this color situation with the VAVs and how they're labeled and if the zones are or aren't. Like, if that workflow doesn't work, we can visit other options. But see if it fits, right? See if you can work doing it that way, and if not, we can change it. Or maybe we can investigate some other option. Like, I don't know if we can highlight, like, the zones in a, like an outline, so that you can at least see everything that's within this zone is in this highlight or something.
Unfortunately, I wish there was a way to, if, as soon as you highlighted that, if it would, but
Yeah.
if it fed these two rooms and you got it off color, I wished it would do that.
I don't know that that's important.
But as long as you.
If we understand the logic in the,
Once you know
if
how
you
to-
can design behind it.
So I'm curious in your feedback on that as we move forward, so play with that a little bit, let us know if you have any feedback there next
It
time.
works, it's just different, but I want you to understand how to drill down and get what you want, because it's all there. It's probably more there than what you're used to, but it's just, where do you find it? It's kind of like, any of you guys drive a Ford?
Unfortunately.
Well, see, this is kind of like driving a Chevy, so, I mean, it's a little different. I'm just kidding, I'm actually a Ford guy.
We're gonna go compare the thermostat locations on the plans and in the field to what's on the graphics, make sure that we get those right. The VAV labels on the grid, Josh wants to go ahead and do that?
Yeah.
Okay, so we'll go and put label maker labels on the grid where the VAV boxes are for all the STs. Floor plans and the VAV documentation, maybe we'll do second floor. I'll give you the as-built and we'll go ahead and link them there. Can they link them, or is that something you need to upload?
In the future, I think we can show them.
I was gonna say maybe next time we can demo
Because
that.
it's on the backside
Okay,
of, it's underneath the settings and stuff, on the backside.
maybe we
It's
show them,
possible.
maybe we show them how.
Yeah.
For next time, I'll send you those first couple for second floor, and we'll get those uploaded, and we'll see if that works. And if not, we can look at other options. And then the last thing here was just how we change the descriptions on the floor plans themselves, and we'll figure that out for next time as well.
Yeah, because there's like a little app that runs that handles the documents server, like a document server. So there's a way to do it, replacing them, do in the future. Already know that what you have here are not 100% as built it. So when you look at the VAVs, those VAVs are like our submittal. But before we get done with the job, there's going to be, we've got to update those documents. So the 100% has. Okay.
Take 2 seconds, fill out that little survey for me. Any information there is helpful. The QR link here also is for the video from last time. If you know how to use those on your phone, those are on your agenda, so you can check out that the video from last time. And the only reason to really do that is to give me any feedback, right? If it's not helpful at all, or maybe if you did this, I could actually use them in the future, because I want to make sure that we're spending our time wisely here and giving you what you need.
Real quick,
Yeah.
anything that, I don't know what the agenda is for Thursday, did you cover that?
That's the next item. Yeah, because we're gonna kind of push some of this stuff into Thursday again.
Yeah.
We're gonna continue with the VAVs. We're gonna talk about the trending. We're gonna talk about reports. We're gonna talk a little bit about alarms
Just
and,
on how much time it took today, I think it'll take almost all the time
Yeah.
just to cover the rest of this stuff.
yeah. So we'll focus mainly on the
I think I'm
VAVs
excited.
next time, if we have some additional time. Most of the other navigational stuff gets covered through that, right?
Yeah.
Because that's what we were talking about, was the alarms and the set points and how to change that stuff, which we're covering as we go through these VAVs,
So
so.
your next Thursday is roller coils, fan coils, crack
Yeah,
units,
we're not
radios,
gonna
we
make it.
probably.
I think we're gonna,
shorten that.
that's what, yeah.
Push back into there.
So we're gonna push everything back here a week or a day.
We'll catch up, because once you get into the other stuff, you've seen the same stuff over and over.
Yeah.
Because it's in the same spots, all the other.
Air coolers.
Yeah. We'll adjust the
And, you know, time frame wise, and so I was talking to Joe initially was I told him, sometimes it's easier just doing an hour and a half segments, just because it's about all I can pay attention to, something's about an hour and a half. I can't watch a 2 hour movie at a movie theater, I'm asleep, but if, we can do more, less, whatever, if that's.
Yeah. Our trick is trying to catch both shifts here, right? And trying to keep some of you a half hour late and bring Mitch in and out half hour early, so, you know, it's totally up to you guys, right? If you would like to lengthen this, we're happy to do that. You can get more done in shorter, you know, overall time period, or just carry on and let us know. We're flexible, for sure, so maybe we'll take a survey next time.
For our guys,
See what you think.
be here at least 5 minutes early next time to get logged in. That way we're maximizing our time while we're here. We got about an 11-minute delay today,
Yeah, and I
which
think
doesn't sound like a lot, but that's 11 minutes that we can still be discussing things, so.
Yeah. And now that we got the blue jeans all hooked up, that'll be easy next time, so I think we'll get better as we go here, for sure.
Great.
Thanks for the input and
Well,
patience.
thanks, guys.
Anything else? Good?
Yeah, and if you're poking around and you end up coming across and have a question, jot it down. We want to make sure you 100% comfortable with whatever you're doing.
Thanks.
One thing I did jot down for today was just, you know, once we get through kind of the understanding of how the VAV works, then we're going to need to understand what are the first 12 months. Obviously, we don't have to worry because we got them on up for warranty, right?
Yeah.
But after that, what are the next steps to diagnostics? These controllers that you're referring to are on each VAV. What does it take to replace that? Is that something we can just keep on the shelf, plug it in?
I'll bring controllers next week. We're
Downloads
talking
happen
about VAVs
automatically.
anyway. I'll
Yeah.
show you what they look like. I'd rather you swap them out.
Yeah, I think that'd be good.
Because you got a cut sheet in there on the page to kind of show it to you. But
Because that's the only thing that's ever going to fail, right? Typically in a metal box with a damper.
And hopefully, I mean, that you don't have very many.
Right.
Because usually electronics, hopefully I've replaced all the ones that are failed, because they'll fail in shipping, they fail during construction, they fail damage during installation, and you won't have those issues. So after a period of time, the number one thing that happens with VAV boxes, and you guys probably are, how old is this hospital?
We opened in 10, so yeah, we'll be.
We've got the Johnson Control VAVs, so you've got probably another 15 years, but those polytube cables on the inlet of the VAV boxes start getting brittle. And that's a lot of times what you're working on. I mean, y'all don't have to place a lot of Johnson VAVs, do you?
No, but we replaced plenty of actuators, buckets of actuators.
Control valve actuators.
Yeah. And damper actuators back in surgery.
Hopefully you won't have to did they use the Johnson valves or did they use William or anything?
No, they use Johnson.
I don't think you'll have as many valves.
Okay. Awesome. Thank you guys. Appreciate it.
Hey, go ahead and turn your computer off, get it back in the cart.